We are now in lesson 1-2, section 1-2 in your book. And as you can tell by my title, we have moved from solving equations, linear equations, and now we're going to be talking about solving linear inequalities. And so hopefully you remember from your Algebra 1 experience, instead of equals in our statement, we're going to be dealing with either greater than, less than, or greater than equal to, less than equal to. So the solution, if there is a solution, to these linear inequalities will not just be one number, but it will be a range or a whole set of numbers. So a little bit different. Now the way we go about solving them, using inverse operations and in PEMDAS in backwards, basically, reverse order of PEMDAS, that's all the same. But the result, the solution, is quite different when it comes to inequalities versus equations. So you can see my standards here that we're going to be covering, our gray standards. You don't need to write this in your notes. And this is our target. We want you to understand by the end of this lesson, how do you solve what we would call one-step inequalities. Only one step is required. And then when more than one step is required, how do you go about solving those? So there is some similarity between this lesson and our previous one in solving equations. So let's just get right into some examples to help you with the homework. So what I'm about to do, I've made up some examples that follow pretty closely to the 11 to 21 odd portion of your homework assignment. So let's take a look at these. Probably this first couple will be very easy. Remember, we're trying to isolate, in this case, n on the left side of this inequality. And just like we did with equations, we need to undo adding 9, and we do that with subtraction of 9. Okay, so this is what we would consider a one-step inequality. So we have n is less than or equal to -5. So we've done the first sentence of the instructions. Now we need to do the second sentence, which says graph the solution set. And the graph of these linear inequalities, where there's only one variable, that's going to be done by using a number line. Okay, so I'm sure you've seen this before. I like to put 0, and then I like to put the number that we see as part of our solution, one of the endpoints of our solution, 0, and then where is that number in relation to 0? Obviously it would have to be over here on the left. We'll just approximate where. And you may have learned several different ways of showing a number line, and I'm okay with whatever you pick. This is the way I do it. Because it says less than or equal to, what that means is when we're talking about all of the numbers that are included in the solution set, we need to include -5 as one of those solutions. So for that reason, when we show the graph, we're going to make a solid dot above -5 to show that it is one of the numbers in the solution. And the rest of the numbers that represent the other part of the solution will be all of the ones to the left, or the less than direction. So this might help for some people. I noticed in my experience that some people get a little bit confused on how to do the graphs of these inequalities. Well, if you can always position, now in this case it worked out this way that our variable is on the left side of the inequality and the number is on the right. Well, whenever this happens, you can always draw your arrow in the direction that the inequality points. It's pointing to the left, so I drew it going to the left. Well, you might be asking yourself, well, what if we had solved an inequality and it came out the other way? Let's just throw up a random example here. I'll just use the same numbers, but let's just say we came down to the bottom of an inequality and it looked like this. Well, I can't just use that same technique of drawing the direction that the inequality points, because the variable in this case is on the right. So the only time I can use that draw in the same direction idea is when the inequality is situated like this. Variable first, inequality. Notice I went ahead and changed it, and when I switched places with these, I had to switch the inequality as well. Now I can just draw the line indicating the solution in the same direction that the inequality points. So just a word to those who may struggle a little bit with drawing the graphs of these inequalities. So we finished our answer for letter A. Let's try letter B. Well, letter B, we got to be careful, because there's a rule when it comes to inequalities that says if we multiply or divide either one of those operations by a negative number, then it's going to be necessary to switch places with the direction of the inequality. Switch the direction that the inequality points. Okay? So once again, in this particular problem, it's required of us to divide each side of this inequality by a negative number. And we have to remember that rule that we were taught early on, pre-algebra, Algebra 1, that anytime you do divide or multiply, it pertains to either operation, by a negative, then that means that you must reverse the direction of the inequality. So it originally was pointing at greater than, equal to, we changed it to less than, equal to, and then of course negative 4/8 is reduced to negative 1/2. Okay, so very important. I'm going to take a moment. I do this in class anyway. Some people they're curious, and I'm glad. Some people wonder, why is that necessary? Why do we have to change the inequality? And just a real simple illustration using just a basic number line here. Let's just put a couple of numbers, -3 and +5. Okay. If we were to express what I've written here on this number line in inequality form, we would say that -3 is less than 5. Simple enough, easy to understand. Well, when like we did over here, we divided by a negative number, -1 or -8. Let's do the same thing here. I'm just going to divide both sides of this inequality by -1. Okay. And what's the result? Well, now I get +3 and -5. Well, would it still be true if I left this as less than? Obviously not. So dividing by a negative number meant it's required to make this remain true. I'm going to have to reverse the direction of the inequality. So that's just a little illustration of why that little rule is necessary. I've had some people ask me that in the past. All right. Continuing on, we're still doing some examples to help you with 11 through 21 odds. So again, we're following our same thinking that we would if this were an equation. So the first thing I'm going to do is add 7 to both sides. All right, -3z is greater than -7. All right, and then dividing both sides by -3 gives me +z. Remember our rule, I divide by negative, so I switch, and -7 divided by -3 is +7/3. Okay, so now we're going to have to graph a fraction, and I noticed in your assignment you do have a couple of answers that are in fraction form, and you're going to have to graph them. So here's what I'd like for you to do. Just a little bit extra. Just to give you a little bit of number sense. Here, 7/3, if you need to change it to a mixed number, that might be helpful for some of you. As a mixed number, remember that's 2 1/3. Okay, so what I want you to do in cases like this is just show me 2, show me 3, and then approximate where you think about a third would be in between. And obviously it's not going to be exact. Now you shouldn't be putting it over here, but give me an approximation of where you think a third might be. And then since it just says less than, we're going to leave an open circle, because 7/3 is not going to be part of the solution, but all the numbers to the left of 7/3 will be. So that is the solution in inequality form, and then we also have the solution in graph form. Okay, letter D. We got several steps, we got some operations to undo, and we need to make sure that we do them in reverse PEMDAS order. We mentioned this situation in class yesterday, right here. Remember, dividing into 7n by 6 means that I've also got to divide into 3. So because these are inseparable in this division process, I'm going to show, even though the problem doesn't have it, I'm going to put parentheses around this. And then I'm going to undo in this order. I'm going to undo the addition, because that's the lowest of the 3 things I see. I see addition, I see division, and now, because I put them there, I see parentheses. So I'm going to undo in that order. I'm going to undo the addition, then the division, and then what's in the parentheses. So the first thing is to undo addition with subtraction. Okay, and sorry about that, it should be 4. I'm not going to show the steps, I'm going to save a little bit of time, but hopefully you can see I subtracted 25 from both sides. Then I'm going to undo this division. I'll keep my parentheses as a reminder. I'm going to undo the division with multiplication. So let's go over here. 7n plus 3 is less than 24. And then finally, I'm going to undo, now I'm down to this. I've got 2 operations. I'm going to undo addition, again, before multiplication. 7n is less than 21. N is less than 3. And now we do our number line graph. I'll just put it over here. 0. There's 3. It's an open circle, and again we're shading to the left. We have a lot of examples shading to the left, don't we? Okay, less than. All right, 23 through 26, we are back to taking a word, a sentence, and converting it over into an algebraic inequality. And then we're going to go the additional step and solve what we've come up with. All right, so remember from our previous lesson, 15 less than, well, that implies subtraction, the product of 2 and a number. So I'm going to do 15 less means subtract 15 from the product of 2 and a number. Okay, and remember is just another way of saying equals. Well, hold on, sorry. Is less than, I got to read the whole phrase, is less than 33. Okay, now we solve it. 2n is less than 48. I just added 15 to both sides, and then n is less than 24. And so we do our number line. I'll just say this is 0, this is 24. Open circle because it doesn't say or equal to, shading to the left. All right, letter B. The quotient of the sum of, okay, the quotient of, that's division, the sum of, that, this will be our numerator, the sum of 4 and a number, and 9, that's, in other words, the denominator of our quotient, our division problem, is at least, interesting. What does it mean to be at least -7? Well, it's -7 on the low end, and then it can be anything higher than that. So just think of -7 as the bottom number, and then we go up from there. Okay, so how do we express that as an inequality? Well, that would be greater than or equal to, because it can be -7. It's at least -7, but it could be more than that. -7 at the very lowest. All right, so there we are with our inequality. So now let's solve it. So my first move is to multiply by 9 on both sides. Okay, I just multiplied both sides of the inequality by 9, and now I'm going to subtract 4 from both sides, and I get the inequality n is greater than or equal to -67. So we'll just put a little number line over here. I'll just say this is -67 over here. It's or equal to, so I need to remember to do a solid circle, and it's greater than, so I'm going to shade to the right, the greater side. And that's my answer. Okay, got one more of these. The difference of 5 times the number and 2, okay, pretty easy. 5 times the number and 2 being subtracted, that's what the difference of refers to, is greater than the number, okay, greater than, and then we put our variable n again to represent the number. Okay, so remember, in cases like this, variable is on both sides of the inequality. We need the variable on one side only. So I could subtract n from both sides. I'll just go ahead and show this, because I want you to notice I see a lot of issues over the years, and I remember issues that people have. This is still an inequality that has two sides. It just so happens that the right side now is 0. N minus n. Any number minus itself is 0. Okay, now I'm trying to solve for n, so I add 2 to both sides and divide by 4 on both sides, and 2 divided by 4 is a half. So once again, I'm dealing with a fraction. So I'm going to do this. I'm going to put 1 and 2, the two whole numbers that the fraction is between. And if you want to write in a half, that's okay. I'm just going to put a little circle to indicate halfway between 1 and 2, open circle, and it's greater than, so I'm going to shade to the right. Okay, so that should help you with problems 23 through 26. And then the last part of your homework will be more of solving inequalities, so just have a few more examples. We're going to solve and then graph just like we were doing before. So let's just walk our way through solving for x here. The first step is to subtract 13 from both sides. So -6x is less than 12. And now I'm going to divide by -6 on both sides, but again, there's that rule. I'm dividing by a negative number, so that means I got to switch the inequality direction and get to my final solution, which is all the numbers that are greater than -2. Well, here's a picture, number line form, of what those numbers are. Here's 0, here's -2. So here's an illustration of what we're talking about. We're not going to consider -2 in the solution, but anything bigger than -2 will work. Okay, letter B, distributive property, to get rid of this group, the grouping symbols. So -3 times 2x, -3 times 1, and now we have a problem very much like we had before. I'm going to add 3 to both sides. I'm going to multiply by, or divide by -6. You could multiply by -1/6. That's okay. But in either event, you need to switch the direction because you're operating with a negative number, and -24 divided by -6 is +4. So any number greater than 4 should make this true. And if you want to check your work on any of these, just pick a number like 5. Let's input 5 in for x. Let's see, 2 times 5 is 10. 10 plus 1 is 11. Negative 3 times 11 is negative 33. Negative 33 is less than negative 27. So since one of the numbers greater than 4 worked, we can be assured that all of the numbers greater than 4 will work. Okay, so here's our picture in graph form. There's 4. 4 is not included. It does not say or equal to. So we're going to leave an open circle above 4, and we're going to shade the greater than side. All right, very good. I think these two will wrap it up. We have this y variable on both sides, so I'm going to kill the little one. The smaller of the two is the negative 13y, so I'm going to add 13y to both sides. And that gives me 8y plus 4 is greater than, this is 0. 0 minus 36 is negative 36. Okay, I'm going to subtract 4. I need to undo addition first. 8y is greater than negative 40. And now I'm going to divide by 8 or multiply by 1/8, really doesn't matter. And just want to point out, because some people get a little confused with this, the rule of switching the direction of the inequality only applies when you're dividing by or multiplying by a negative. It's not dividing into a negative. So notice I did not switch the inequality direction in this case. So my solution will be all the numbers that are bigger than negative 5, and we don't include negative 5 in that solution. So we're going to leave open circle, shade to the right. Okay, interesting one here, letter D. You've got one a lot like it. Number 36 is a lot like this. So let's get rid of the fractions. And the way we get rid of fractions, we clear out the denominators by using the lowest common denominator for 3 and 4. Think of the lowest number that both 3 and 4 will divide into evenly. And that happens to be 12. So let's do this. Let's divide 3 into 12. And you're thinking, okay, that's 4. All right, 3 divided into 12, that gives me 4. So let's think of it this way. The result of dividing 3 into 12 is 4. And I'm going to now multiply 4 times this numerator. Okay, so the result will be 16z plus 12. Now I've gotten rid, or some people use the term, I've cleared out the denominator. I no longer have a fraction after multiplying by 12. Okay, so let's do the same thing on this side. Divide 4 into 12. That should be 3. Okay, so think of it this way. I'm going to mark these out and just make it 3. And now multiply 3 times that numerator. 3 times 6z, 18z. 3 times negative 2, negative 6. And now we're back to familiar territory, no fractions to deal with. Let's kill the little one. So I'm going to subtract 16z from both sides. That's 0, 12, 2z minus 6. All right, add 6 to both sides. 18 is less than or equal to 2z, and divide by 2. 9 is less than or equal to z. So be careful here. Notice this is number on the left, variable on the right of the inequality. So you might be tempted just to graph the line in the same direction that the inequality points. A lot of people just think that way. Well, the only way you can do that is if the variable is on the left, number is on the right. And in switching places with these, you also have to turn the direction of the inequality. Okay, so saying that 9 is less than or equal to z is really another way of saying z is greater than or equal to 9. But looking at it in this form helps people with graphing. And not everybody struggles with that, but some people do. So here's your graph. Okay, so here's 0, 9. 9 is included this time, so we're going to solid circle, shade to the right. Okay, well, I hope those examples will help you with this assignment. And if not, if you were absent and you missed this lesson, hopefully you took good notes and try the homework. And if you need more help, please come and see me, and I'll be glad to help you.